Hello students, welcome to my YouTube channels. Now I am going to discuss conductions of heat transfer through the hollow cylinder. Already conduction of heat transfer through the composite wall we discussed, we given and some problems already I solved. Part 1. Now conduction of heat transfer through the hollow cylinder. After this will be there spherical. So 3 parts will be there under the conduction. Okay. All 3 parts will be very important and you have to study separately. Composite wall, first concept you get. Now here, what we did in the composite wall, we got the thermal resistance for 1 ball, 2 ball, 3 ball, then conduction and convection mixed together, we got the thermal resistance, then heat flow is equal to temperature, overall temperature divided by thermal resistance. Similar things we are going to do the here. But what is the here? Thermal resistance for the, suppose single wall will be there. So this is the one single cylinder tube, inner and outer. This is inner and outer wall. Inner radius is R1, outer radius will be R2. And we are just considering one elemental area, whose thickness is dr. So what we know that Fourier's law of heat conductions, Q is equal to minus Ka dt by, if we will take the plane wall dx, we are taking thickness of the dx. Composite wall. Now this is radius, so dr. This is the dr. Now what is the, how we'll get the thermal resistance here? So see here, area cylinder. What is area of the cylinder? 2 pi RL. What is this one? Area of the cylinder is 2 pi R. 2 pi RL. We'll substitute here. So Q dr is equal to minus K 2 pi RL dt. This we know. If we'll integrate both sides, why we are studying this derivation? To remember the formula. If you know the derivations, then you can remember the formula. Otherwise, already formula will be there in the data book, but you should know how we are getting the thermal resistance. So we will integrate both sides. Q dr. What is the limit of the dr? R1 to R2. Inner radius, outer radius. So R1 to R2. Now what is the dt? So other things, this will be, okay, R. You bring R here. dr by R. We bring R here. So what is with the minus K, or you write 2 pi constant, no, like this in order you write 2 K pi L. L we taken is capital L, no, so you write here capital L. Okay, there also I given capital L. So length I taken capital L, no, write the capital L. So here also write the capital L. That will be better. Capital L, then dt. What is temperature? T1 to T2. So inner surface temperature will be, T1, outer temperature will be T2. So we'll integrate temperature T1 to T2. Now we'll integrate. So Q will equal to Q. Integrate dr by R ln R. So limit R1 to R2 is equal to minus 2K pi then is 2K pi L. So 2K pi L dt, temperature T1 to T2. Upper limit by lower limit. Now ln R. So what we can write here? Q ln R2 by R1. R2 by R1 equal to minus. So what we'll do here? Okay, write one more steps. 2K pi L T2 minus T1. If we'll remove the negative, write T1 minus T2. So Q ln R2 by R1 2K pi L T1 minus T2. Now what is thermal resistance? I am going to write here. See here. Q is equal to ln R will be down. So T1 minus T2 ln R will come denominator ln R2 by R1, and this part 2 pi KL or 2 pi KL or 2K pi L, this will be down 2K pi L. What is this one? This one is the thermal resistance for the hollow cylinder. So this is called overall temperature minus R thermal for R thermal. So this what is thermal resistance for the hollow cylinder. So what is R thermal equal to? R thermal equal to ln R2 by R1 divided by this is called thermal resistance. So see, conductance what we got? Means plane wall. This also conductance only plane wall what we got? Overall temperature difference divided by L1 by K1A. What is this one? T1 minus T2 divided by R thermal. See, this R thermal, where R thermal equal to this for hollow cylinder, R thermal equal to this for plane wall, R thermal equal to plane wall. See, both same, no? But R thermal for plane wall, like this sphere also will be there. We'll go slowly, step by we'll go. So how to remember for single wall? How to remember for the single wall? See here, either this or this. This means where R thermal equal to this, Now look here. We know the one block, one inner and outer cylinder. Because cylinder is there, so cut section. If you cylinder is there, suppose iron rod is there, it's called cylinder. What is the cross section? Cross section nothing but circle only. That's why we draw the circle only. Okay. So this part of the cylinder, 3-dimensional diagram. So cylinder cut section is circle only. Okay. So now look here what we'll do. We'll correlate. Now suppose two cylinder will be there. How we'll write the formula? Already there. I will rub it this part. Now look here. This one now we'll give 2. See here. How to remember? So that only I'm telling. 1, 2, R1, R2, T1, T2. Then what is this one? This one thickness. This is called thickness. Now another one. What is this one? T3. This is T3. Okay. R1, R2, R3. So this one will be R3. Another will be R3. So now how to write the formula? Q is equal to, see here, Q is equal to overall temperature difference T1 minus T3. Here what we wrote? T1 minus T2. Now here 1 and 2, 3 layer. What we write here? Thermal resistance, where ln R2 by R1 for first one, 2 pi KL. 2 pi KL plus ln R3 by R2 divided by 2 pi KL. See, this is the formula for that. If 2 will be there, concentric sphere hollow cylinder will be there, 2 will be there. Now last part what is? If convective will be there, inner and outer will be, some air film will be there, convective surface will be there. Convective surface means change the phase. So that once you know, hollow cylinder work also over. So for this one, for one cylinder, for two cylinder, now I am going to give the conduction and convections both. Once that you know, your work is over here, then we'll solve the problem again. Okay, so now listen here. I will do the diagram first. I will draw the diagram now. Look here. So first inner surface. Inner surface, suppose this will be the R1. Here temperature, hot fluid. Temperature, hot fluid. Now next, one layer. This is temperature T1. This is the temperature T1. Now another layer. That is temperature T2. Temperature T2. Then outer layer. Outer layer will draw the different color. This is called outer layer. Outer layer. Suppose this temperature will be TCF, cold fluid. Hot fluid inside, hot fluid, cold fluid. So this will be R1, R2, R3. So see this R1, R2, R3. R1, R2, R3. Okay. So this R1, this is cold fluid, no? So make it this R1, this is R2, this is R3. This will be the, like this cylinder will be there. So this length will be L. This length will be L. So how to write this? This will be the convective, this also will be convective. Then 2 is there, this 2 will be there conductive. So direct formula how we write here? Q is equal to overall temperature, what is? THF, temperature of the hot fluid, minus temperature of the cold fluid. Then what is convective heat transfer? Already you know. Q is equal to HADT. Q is equal to HADT. What is A is equal to here? 2 pi RL. 2 pi RL. Substitute here. What will come? H 2 pi RL dt. Q is equal to. So what will be there here? Q is equal to what we can write? See here. dt by 2 pi R, you keep it here. Okay, just wait. 2 pi R dt by, what will be there here? 1 by HA. Oh, 2 pi R, no, HL. So what will be there? 1 by convective heat transfer, no? So convective heat transfer will be 2 pi L, 1 by HF. This H into R1. So 2 pi L, 2 pi L HR. What is H? Heat transfer coefficient. R is radius. So this is for convective heat transfer for the hollow sphere. Convective heat transfer for hollow sphere. See one more time. HADT. Previous video also I given HADT for the convective heat transfer. H is convective coefficient. Now A is equal to 2 pi RL. Temperature difference. Now Q is equal to 1 by HR1. HR1, it will come down. See here, 2 pi L will be top, 2 pi L will be there. So this is nothing but why 2 pi L is taken? Because 2 pi L common will come for everyone. So that's why. So this will be the convective part. This will be conduction part. This is conduction part. This is also convective part. So what is the overall formula here? Overall formula here you see here. That only you have to remember, and that formula will be there also in the data book. No need to remember also, but you should understand. So here Q is equal to 2 pi L. 2 pi L will be common for this, no? 2 pi L. So what will write here? 1 by hot fluid. 1 by temperature of the hot fluid. Temperature of the hot fluid into R1 plus convective. What is conductions? Conductions will be ln R2 by R1 divide by 2 pi L already there here. So thermal conductivity of K1 plus ln R3 by R2, then thermal conductivity K2, then plus, the space not there, no, so here plus, right from now, okay, we'll start from again. So here see here, Q is equal to 1 by temperature of the hot fluid and R1, then ln R2 by R1 K1 plus ln R3 by R2 K2 plus convective heat transfer. What is 1 by THCF, temperature of the cold fluid, TCF, hot fluid, cold fluid, then R3. This is the overall convective heat, overall composite hollow cylinder heat transfer. Composite hollow cylinder heat transfer formula. So this way we can remember. See, single will be there na, this part only T1 minus T2 or if 2 na, T1 minus T3 2 times, 3 na, T1 minus T4 3 times. If convective there, both side convection, 2 block, conduction, 2 is convection. This is the overall heat transfer of the hollow cylinder. So this, if you know that this concept, based on this problem, once they will give, only this formula will write, substitute all the value will represent in the diagram, that value will shift here in this formula and we will get the answer. Okay, students, revise this, then based on this, we will give the problem in the next video. Okay, thank you, students.